Cell diagram is a shorthand description for a galvanic cell. What you do in a cell diagram is you list all the species that are involved in your cell, starting with, and you have to do it in this order. You start with the inert electrode for the anode, if any. Sometimes your anode half reaction doesn't involve a piece of metal. Then what you do is you have to put something in there, like a platinum wire, to be able to allow the electrons to come out, okay? So usually you would use a platinum wire or a graphite rod, that's carbon, okay? Then you list the anode reactant, just the actual species, the ions or molecules involved, then the anode product. So the anode reactant is the subspecies that is what? Oxidized, and the product would be what it's oxidized to, and then the cathode reactant, and then the cathode product. So the cathode reactant is the species that is reduction of the cathode, and the cathode product is the product of the reduction. And then if you have again an inert electrode in your cathode, okay, if your reaction in the cathode doesn't involve a metallic solid, then you have to put something in there, an electrical conductor there, to be able to complete the circuit, okay? And if you want to provide a little more detail, you can specify the physical states or the concentrations of your reactants and products in parentheses, okay, including the inert electron. Now, when you draw your cell diagram, you separate the items that are in the same phase by a comma. So if you have, for example, in your anode, you have iron and with a +2 charge and a +3 charge, you separate them by a comma. If they're in different phases, for example, a piece of silver metal and a silver ion would be separated by a vertical bar, because your silver metal will be a solid and your silver ion will be an aqueous solution. So you separate them with a vertical bar. Okay? If your two compartments are separated by a salt bridge, you draw two vertical bars to separate the anode from the cathode. Okay? Sometimes it's possible to set it up so they're all in one solution. Okay? And in that case, you just do one bar. Okay? And like I said, your inert electrode is usually either platinum or a graphite rod. You have to use that if your reactants are neither one of the reactant or product is a metallic solid for your reaction. Okay, so how would you interpret this cell diagram right here? Which one's the anode? We start with the anode, right? And then you end up with the cathode. First, let's look at the easiest ones to identify right here. What does this represent? That's a salt bridge, right? And so, anode on the left, salt bridge, and then cathode on the right. So what would this setup look like in the laboratory? I would have, okay, two half cells, right? I'm going to have a salt bridge. And what do I have on the right? What's the metal that sticks out of my cathode? Copper. So I'll have a piece of copper there. And I'm going to have copper ions in solution in my cathode. What do I have on the left? Okay, first of all, why is this thing a vertical bar there? Because your copper is a solid and your copper ions is an aqueous solution. So you put a bar to separate them. What about H plus and H2? So you have an acid here with H plus, right? And what do you know about H2? That's a gas, right? So I have to be bubbling in some gas in here. So I have to have some kind of contraption here where I can bubble in some gas. Okay, so maybe a tube that would bubble in some hydrogen gas there, a source of hydrogen, right? And what do I need to have here? Since I don't have a piece of metal in my anode reaction, what do you think is my anode reaction? How is H plus and H2 related? If I want an oxidation half reaction, how can I write an oxidation that involves H plus and H2? H plus H2 would give you what? 2H plus 2 electrons, right? That would be the oxidation. So I would have to stick a platinum wire in here for it to be able to conduct electricity. Okay, so that's what that cell diagram would look like. Okay.